Hello students, this is the next lecture for TY BCom students. Subject name is Business Statistics second paper. Name of the topic is Mean and Variance of Binomial Distribution. And we have to see some examples and problems based on this topic. Mean of binomial distribution is nothing but expected value of x is equal to n into p. Variance of a binomial distribution is given as variance of x is equal to npq. So we can say that expected value of x is always greater than variance of x for binomial distribution with parameter n and p. See the example. Let x be a binomial random variable with parameters n and p. If n is equal to 10 and expected value of x is equal to 6, find p and variance of x. Now, the information which is given is that x follows binomial distribution with n is equal to 10 and parameter p. So, expected value of x is given as np. We can write this as 10p. And expected value of x is given as 6. So, 6 is equal to 10p. Therefore, p is equal to 6 upon 10. So, value of p is coming as 0.6. If value of p is coming as 0.6, q will be 0.4. And we know that variance of x is given by the formula n, p and q. So, which is equal to 10 into 0.6 into 0.4. So, if we multiply the three values, the answer is 2.4. Next example. Let x follows binomial distribution if expected value of x is equal to 9 and variance of x is 3.6. Find the parameters n and p. So it is given that x is a binomial random variable with parameters n and p. Given that expected value of x is equal to 9 and variance of x is equal to 3.6. So we can say that np is equal to 9 and npq is equal to 3.6. So divide the terms npq upon np is written as 3.6 divided by 9. So np gets cancelled with np. So value of q is equal to 0.4. If q is 0.4, p can be calculated as 1 minus 0.4, which is equal to 0.6. Now np is equal to 9. So we'll replace p as 0.6 in this equation. N into 0.6 is equal to 9. Therefore n is equal to 9 upon 0.6. So value of n is equal to 15. So for this example, n comes out to be 15 and value of p is equal to 0.6. Example. Let x follows binomial distribution with mean is equal to 5 and variance is equal to 2.5. Find first part of the problem, probability x less than or equal to 1. Second part of the problem, probability x greater than or equal to 2. Now in this case, x follows binomial distribution with parameters np. Expected value of x is equal to 5 and variance of x is equal to 2.5. So np is equal to 5 and npq is equal to 2.5. Again we will divide the terms. Npq upon np can be written as 2.5 upon 5. So q comes out to be 0.5. If q is 0.5, p is also 1 minus 0.5 is nothing but 0.5. Now np is equal to 5. Therefore n into 0.5 is equal to 5. So therefore n is equal to 5 upon 0.5. So value of n is coming to be 10. So therefore x follows binomial with n is equal to 10 and p is equal to 0.5. We see here we want to find probability x less than or equal to 1 and probability x greater than or equal to 2. So the remaining part we will see the Pmf of binomial distribution is given by probability x is equal to ncx, p raised to x, q raised to n minus x. The range of x is starting with 0, 1, 2, 3 up to n and equal to 0 otherwise. To find probability x less than or equal to 1, we have to start with probability x is equal to 0 is equal to 10c0, 0.5 raised to 0, 0.5 raised to 10. So 10C0, the value is 1. 0.5 raised to 0, again the value is 1. And 0.5 raised to 10, the value is given as 0.0009765,625. So the answer for probability x is equal to 0 is given as 0.0009765,625. Then we will find probability x is equal to 1, which is equal to 10C1, 0.5 raised to 1 and 0.5 raised to 10 minus 1. So 10C1 the value becomes 10, 0.5 raised to 1 the value becomes 0.5 and 0.5 raised to 9 the value is 0. So the final answer is coming as 0.009765625. So if we add both the answers, we are getting the final answer as probability x less than or equal to 1 is equal to 0.0009765,625 plus 0.009765625, which is equal to 0.010742187. Then we have to find probability x greater than or equal to 2, which can be written as probability x greater than or equal to 2 is equal to 1 minus probability x less than 2. So we already have calculated probability x is equal to 0 and probability x is equal to 1. So 1 minus sum of probability x is equal to 0 and probability x is equal to 1. So which is nothing but 1 minus 0.010742,187. So the answer is 0.989257812. Now see the next example. 20% bolts produced by a machine are defective. Determine the probability that out of 4 bolts chosen at random, first part of the problem, at most 2 bolts will be defective. Second part of the problem, at least 1 bolt will be defective. Now bolt will be defective, bolt will not be defective. So it's a Bernoulli trial. So therefore we can apply binomial distribution. Let x denote number of defective bolts produced by a machine. So x follows binomial with n is equal to 4 and p is equal to 0.20 because 20% are defective. So value of p is directly given as 0.2. The Pmf of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x. The range of x is starting with 0, 1, 2, 3 up to n and equal to 0 otherwise. Then we will replace the parameters in the probability mass function. So probability x is equal to 4cx, 0.2 raised to x, 0.8 raised to 4 minus x. Now in the first part of the problem, we have to find at most 2 defective bolts. So that is nothing but probability x less than or equal to 2, which can be written as probability x is equal to 0 plus probability x is equal to 1 plus probability x is equal to 2. So we will find all the 3 probabilities as probability x is equal to 0 is equal to 4c0, 0.2 raised to 0, 0.8 raised to 4. So 4c0 the value is 1, 0.2 raised to 0 again the value becomes 1 and 0.8 raised to 4 the value is given as 0.4096 and probability x is equal to 1 is equal to 4c1, 0.2 raised to 1 and 0.8 raised to 4 minus 1. So we will calculate it further, which is nothing but 4 into 0.2 into 0.512. So the answer is 0.4096. Probability x is equal to 2 is given as 4c2, 0.2 raised to 2, 0.8 raised to 4 minus 2. Now 4c2 can be written as 4 factorial upon 2 factorial into 2 factorial into 0.2 raised to 2 is nothing but 0.04 into 0.64. So we will solve it further. 4 factorial can be written as 4 into 3 into 2 factorial divided by 2 into 2 factorial. So 2 factorial gets cancelled with 2 factorial. So 2 ones are 2 twos are. So 4c2 the answer is 6. 6 into 0.04 into 0.64. If you multiply the 3 terms, the answer becomes 0.1536. Therefore, probability x less than or equal to 2 can be given as 0.4096 plus 0.4096 plus 0.1536. So the final answer is 0.9728. In the second part of the problem, we have to find the probability that at least one bolt will be defective. So probability x greater than or equal to 1, which is nothing but 1 minus probability x is equal to 0. So we already have calculated this value as 0.4096. So the answer becomes 1 minus 0.4096, which is equal to 0.5904. Next example, it is from TY BCom question paper for 5 marks. 40% bolts produced by a machine are defective. Determine the probability that out of 5 bolts chosen at random, first part of the problem, at most one bolt will be defective. Second part of the problem, at least one bolt will be defective. So getting a defective bolt, not getting a defective bolt. So it's a Bernoulli trial. So therefore it is a problem based on binomial distribution. Let X denote number of defective bolts produced by a machine. So X follows binomial with n is equal to 5 and P is equal to 0.40 because 40% are defective. The Pmf of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x. X takes value 0, 1, 2, 3 up to n, and the probability mass function is written as equal to 0 otherwise. Then we will replace the parameters. So we will rewrite the probability mass function as probability x is equal to 5cx, 0.4 raised to x and 0.6 raised to 5 minus x. Then we want to find the probability x less than or equal to 1, which is nothing but probability x is equal to 0 plus probability x is equal to 1. So let's find the probability x is equal to 0 as 5c0, 0.4 raised to 0 and 0.6 raised to 5. So 5c0 the value is 1, 0.4 raised to 0 again the value is 1 and 0.6 raised to 5 the value is 0.07776. Then probability x is equal to 1 is given as 5c1, 0.4 raised to 1 into 0.6 raised to 5 minus 1, which is nothing but 5 into 0.4 into 0.1296. So the answer is 0.2592. Therefore, probability x less than or equal to 1 is given as 0.07776 plus 0.2592. So the answer becomes 0.33696. Then probability x greater than or equal to 1 can be considered as 1 minus probability x is equal to 0. So we already have calculated this value. So we will subtract from 1. So that is nothing but 1 minus 0.07776. So the answer becomes 0.92224. Next example. If mean of binomial distribution is 2 and variance is 1.6, calculate probability x greater than or equal to 2 and probability x less than or equal to 5. So first of all, we will have to find the parameters n and p. So x follows binomial distribution with parameters n and p. It is given that expected value of x is equal to np is equal to 2 and variance of x is equal to npq is equal to 1.6. Now we will divide the terms. npq upon np is written as 1.6 upon 2. So value of q is nothing but 1.6 divided by 2, which is equal to 0.8. So if q is 0.8, p is nothing but 1 minus 0.8. So that is nothing but 0.2. So np is equal to 2. N into 0.2 is equal to 2. So therefore n can be calculated as 2 upon 0.2, which is equal to 10. So therefore x follows binomial with n is equal to 10 and p is equal to 0.2. the probability mass function of binomial distribution is given as probability x is equal to ncx p raised to x q raised to n minus x. X takes values 0, 1, 2, 3 up to n and equal to 0 otherwise. Now we will replace the parameters. Probability x is equal to 10cx, 0.2 raised to x and 0.8 raised to 10 minus x. Now we want to find the probability x greater than or equal to 2, which can be written as 1 minus probability x less than 2. So which is equal to 1 minus probability x is equal to 0 plus probability x is equal to 1. So we will find probability x is equal to 0 as 10c0, 0.2 raised to 0, 0.8 raised to 10. So the value is 0.107374. Then probability x is equal to 1 is written as 10c1, 0.2 raised to 1, 0.8 raised to 9. So which can be calculated as 10 into 0.2 into 0.134217. So the answer is 0.2684. And we want to have probability x greater than or equal to 2, which can be considered as 1 minus 0.107374 plus 0.2684. So the final answer is 0.624190. Next example. In 20 questions of multiple choice with 4 options, find the probability of getting first part of the problem exactly 7 correct answers, second part of the problem at least 2 correct answers. So getting a correct answer, not getting a correct answer. So the problem is based on binomial distribution. It is a Bernoulli trial, and then we can use binomial distribution. So let x denote number of correct answers. Therefore, x follows binomial with n is equal to 20 and p is equal to 1 upon 4, which is nothing but 0.25. The probability mass function of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x. X takes values 0, 1, 2, 3 up to n and equal to 0 otherwise. Replace the parameters. Probability x is equal to x is given as 20cx, 0.25 raised to x, 0.75 raised to 20 minus x. So in the first part of the problem, we want exactly 7 correct answers. So probability x is equal to 7 can be written as 20c7, 0.25 raised to 7 and 0.75 raised to 20 minus 7. So 20c7, if you expand it, the answer is 77,520 into 0.00006135 into 0.0237572. So if we multiply these 3 terms, the answer is 0.11246061. We want to find second part, probability x greater than or equal to 2, which can be written as 1 minus probability x less than 2, which is nothing but 1 minus probability x is equal to 0 plus probability x is equal to 1. So probability x is equal to 0 can be calculated as 20c0, 0.25 raised to 0 and 0.75 raised to 20. We know that 20c0 the value is 1, 0.25 raised to 0 again the value is 1 and 0.75 raised to 20 can be calculated as 0.003171211. Then probability x is equal to 1 is given as 20c1, 0.25 raised to 1 and 0.75 raised to 20 minus 1, that is nothing but 19. So 20c1 the value becomes 20 into 0.25 into 0.004282. So the product becomes 0.02114141. Then we will calculate probability x greater than or equal to 2 as 1 minus 0.003171211 plus 0.02114141. So the total of these two numbers is 0.0243126. So 1 minus 0.0243126 is given as 0.9756. Next example, it is from April 2018 question paper for 2 marks. For if x follows binomial distribution with parameters np with expected value of x is equal to 18 and variance of x is equal to 12, then find the values of n and p. So expected value of x is nothing but np is given as 18. Variance of x is equal to npq is given to be 12. Now we will divide the terms. npq upon np is written as 12 upon 18. So np gets cancelled. So value of q is nothing but 2 upon 3. So we can say this as 0.66667. So p can be considered as 1 minus 0.66667. So value of p is 0.3333. Now expected value of x is equal to np, which is given to be 18. So n into 0.3333 is equal to 18. So n is equal to 18 upon 0.3333. So answer is 54. Next example, it is 2014 question paper for 2 marks. Let x follows binomial distribution with parameters np if expected value of x is equal to 10 and variance of n is equal to 25. Find variance of x and value of p. So x follows binomial distribution with parameters n and p. Expected value of x is equal to np, which is given to be 10. Value of n is given as 25. So we can say that 25p is equal to 10. Therefore p is equal to 10 upon 25, which is nothing but 0.4. Then to find variance of x, we will write the formula as n into p into q. Value of n is given as 25. Value of p we have calculated as 0.4. If p is 0.4, q will be 0.6. So 25 into 0.4 into 0.6. The answer is 6.